Kia ora koutou, Reese from QuickSense here, and today we're looking at quartiles in the interquartile range. Now, what we mean by quartiles is just that if I was to divvy up all of the data into 4 equal boxes, 4 quarters, then let's have a look at it. So here's the box of all the data. Well, let's draw a more rectangular box, doesn't have to be perfect. Half, dividing it up into 2, so there's half on this side, half on this side, but we want to do it again. So that I've got 4 boxes, each with a quarter of the data in it. These are my quartiles. The interquartile, well, that's the bit in the middle 50%. So let's have a look at this. The following cumulative frequency graph shows the test scores of 120 students. So that means there's 30, 30, 30, and 30 kids in each of the boxes. What is the lower quartile test score? So looking at this here, I'm going to get rid of this half. I'm going to get rid of the half at the top. We have the middle value, which is our median. The lowest value is our min. The max value, that's maximum. And then I have my lower quartile here and my upper quartile here. So we're looking for this one here. So there should only be 30 students below it. Well, what do? I head over to 30. I zoom on out. And what's the lower test score? I come down. The lower quartile for this data is equal to 36. In this next question, we're kind of asked to do a little bit of thinking. So which of the following is not possible given any set of data? Lower quartile equals the median equals the upper quartile. Now this is possible, right? If all of the data was the same, then the lower quartile, the median, and the upper quartile would be equal. So this one, that's possible. The lower quartile being less than or equal to the median, which is less than or equal to the upper quartile, well, we've already shown the case to it to be true that if all the data is true, then they can be equal to each other. But also the lower quartile is going to be lower than the median for most normal data sets. We saw that with the test scores in the previous question. And I'm just going to go back. Right, this is an example where the lower quartile is lower than the median being the 60th student here. Right, we can see that whatever this value is, it's greater than the lower quartile. So that one's fine as well. The lower quartile is equal to the median, which is equal to the upper quartile. Now, you can have this. It's a little bit more unusual, but what it looks like is something we call a left skew graph, right? Where most of the data is up around the top of the data set, right? So it's going to look like this, something like that, right? Where there's a little bit of data down in this end here, but most of it is in this space here. So we can have that to be true. What we can't have being true, and I can immediately see it, right? The median is greater than the upper quartile. That just can't exist. The upper quartile means the data that is above, right? It's the top 25%. The median is the top 50%. So the top 50% can't be lower than the top 25% because it includes it. So, which one of these is not possible? Well, it's our final one.